track our learning on what we've done so far in Unit 2, we're now on 2.4. We have solved multi-step equations in one variable. That means that you only have one variable you're solving for. Justifying steps we have done. Use properties of equality. You always do that when solving with variables on both sides. That's the last lesson that we did. Today, we're going to deal with these two bullets. They're called a special type of equation or special solutions. You're either going to have something called a no solution or something called an identity. So that's what we're going to be working on today. There's special types of answers that you get. So, if you look on this page of your notes, a special solution, what happens is the variable is all of a sudden going to disappear. That's what makes it special. The variable has never disappeared before. And with these special types of solutions, the variable is going to leave. So you still solve everything the way you normally do, and then all of a sudden you're going to notice that the variable is gone. And if the variable disappears, one of two things is going to happen. You're either going to get a no solution. That's going to create a false statement. For example, you might get something like this, 0 equals 5. Because the variable disappears, you no longer get an x. Or you might get something like -1 equals 3. Something that's not true. The other type of special solutions, it's what's called an identity. Identity means they are the same thing. It creates a true statement. So if they're the same thing, you get something like 0 equals 0. True, it does. You get something like 5 equals 5. True, it does. They are the same identity. Okay, so a special solution, to summarize, the variable will always disappear. And then if the variable disappears, you have to tell me, is it no solution or identity? What identity means is no matter what number you pick for x, it's going to satisfy both sides of the equations. A no solution means there's no x that satisfies that particular equation. You can't find an x. All right, let's apply this. So, we solve as normal. I'm going to plus a negative here just to keep my integers straight because I'm not going to let them mess me up. And then I need to get my variable to one side. Should I move the -5 or the -5? Doesn't really matter. I like my variables on the left-hand side, so I'm going to move the one on the right. -5x plus 5x, how many x's do you have?
0.
Nothing. They canceled out. And then what do I have left? That -2 equals
1. I got it.
1. So now you have, my variable disappeared, so it's special. Okay, so you always solve normal, and then you're going to realize if it's special or not. This is special, so is it a true statement or a false statement?
False.
False. So you have to say no solution. Don't say false because that's not the standard. The standard is that you know no solution and identity. So you need to know those two vocab words, okay? No solution means no, not true. Identity means, hey, they're the same. They look the same. All right, so I solve as normal in this next one. I don't need to distribute. Can I combine any like terms on my left side? No. By the way, I'm turning things to plus and negative. Can I combine anything on my right side? Yes. So I'm going to combine my 2x and my 1x for a total of 3x plus a -4. Some of you might already see that they look the exact same, don't they? Do they or no? They do. 3x plus -4, 3x plus -4. Right away I can look at that and say, hey, that's an identity. That's true. But if your eyes can't visualize that, solve it as normal. Subtract 3x, get it to one side. The x's cancel. -4 is left. The x's cancel. -4 is left. Hey, my variable disappeared. This is a special solution. What kind of special solution? It's true, so it's an identity. Using that vocab word, don't just write true. I want you to know what identity means. Alrighty, looking at the next one, plus a negative, distribute, and I'm always using the steps from the first lesson we did, distribute, combine like terms on the same side, get the variable to one side, and then solve. So this is 4x plus a -8 equals 4x plus 3. My eyes see that right away as false. I don't know if you can visualize that because I have 4x on both and then a -8 and a 3. But if you can't visualize that, you solve as normal. 4x minus 4x is nothing. And then you get -8. 4x minus 4x, nothing. -8 equals 3. It's special because my variable disappeared. And it's false. So I say no solution. Okay. One more like this, and the tricky part, kids actually like this better because you don't have to solve as much. It's much faster than normal one solution kind of things. But then what gets tricky is knowing when you use no solution, when you use identity, because it's not always that way. So I'm distributing first, -4x plus a +4, right? -2 times -2 is +4 equals 4x plus 4. All right, and you shouldn't say anything yet. I'm looking here, and I can already tell my variable's not going to disappear. Plus 4x plus 4x. I move in my smallest, and I get 4 equals 4 plus 4 is 8x plus 4. My variable did not disappear, so it's not special. It's only special when your variable disappears. Subtract 4, subtract 4. 0 equals 8x. Still not special because I have my x there. So now what does x equal? 8 times what gives me 0? X is 0. So that's called a one solution. X is one thing. So there's 3 things x can be. One thing, that's what we've always done. No solution or identity. And that's what you have to be able to tell me today. Do you know if it's an identity, no solution, or a one solution, which means the x does not disappear? Oh, great. Types. That's what I was just telling you. Types of solutions. One solution has x equaling some kind of number or fraction, rational number. So that's what you've always done. You've always done one solutioners. And then you could have an identity, which gives you a true statement. Or you can have a no solution, which gives you a false statement. So you're either going to have x equal something, or it's going to be true or false. Okay? The biggest thing that I always try to tell my 8th graders, with identity and no solutions, the variable disappears. And lots of kids forget that. They look at something and now they're like, oh, it's true or false. No, you can only say that if the variable suddenly disappears. That's the only time it's special. Okay, now we're mixing it up. I want you to take a minute and try to solve 3 of these problems at this time. Okay, so the first first thing I would do is plus a negative, of course, and then I would distribute. So 2 times 5 is 10x. Plus a negative 2 equals 3x plus 33. I don't need to combine like terms on either side, so now I'm going to move my variable to one side, minus 3x. And you get 7x plus a negative 2 equals 33. I can already tell that this is not special because my variable doesn't disappear. So I plus 2 to both sides. 7x is 35. Then x is a 5. That is a one solution. Remember that what you do, you either have a one solution, identity, or no solution. Next ones, I'm plusing a negative, distributing, so 4a plus a negative 2a plus 4 equals 2a plus a negative 8. Combining like terms on the same side, so that's my 4a and negative 2a, is 2a plus 4 equals 2a plus a negative 8. I'm looking at this and I can tell that it's going to be a no solution because I have the same thing and then different numbers at the end. But if you don't visualize that, you can minus 2a, and then that disappears. You have 4 equals, disappears, negative 8. That is a no solution. Last example, plusing a negative, 4k plus a negative 2 equals 4k plus a negative 8. I can visualize that it's a no solution because I have the same number and then a different number. But if you don't visualize that, you can solve as you normally would. 4k, take away 4k is nothing. You get negative 2 equals negative 8. That is a false statement, so that would be another no solution. That's how the examples I'll work through with you.